Today's lesson, we're going to look at molar gas volumes. So the syllabus point is here, and this 24 is a special number. And the reason it's a special number is that all gases, no matter what gas you have, if you have 1 mole of that gas, at room temperature and pressure, it will always take up 24,000 centimeters cubed of space, or 24 decimeters cubed of space. So once again, at room temperature and pressure, 1 mole of any gas, so 1 mole of whatever gas, whether it's helium or hydrogen, is approximately going to equal 24,000 centimeters cubed, or 1 mole of gas will equal 24 decimeter cubed. So the conversion is right here. If you want to get decimeters cubed from centimeters cubed, you divide by 1,000. Or if you want to go from decimeter to centimeter, you times by 1,000. So 1,000 centimeters cubed is equal to 1 decimeter cubed. And that's because 10 centimeters is 1 decimeter. So then 1 decimeter cubed will be 1 times 1 times 1. And 10 times 10 times 10 is going to be 1,000. Therefore, that's where it comes from. Now, the famous formula that you should learn is the following. Moles equals V over 24, as long as volume is in decimeter cubed. Okay, so whatever volume they give you, you turn it into decimeter cubed and you divide by 24. Alternatively, you can just divide by 24,000, which is the same effect. So if they give you centimeters cubed and you divide by 24,000, that's like doing it in one step. Otherwise, you would divide by 1,000 first, then divide by 24. So this is your important formula. Whenever you see in a question 24 mentioned, you would know it's this. Otherwise, the buzzword will be volume. But be careful, because if there's also concentration, then it's a different formula. So this only really is for gases, it's not for solutions. The solutions topic is like the next lesson of calculations, essentially. So if you prefer a triangle, there's your triangle. Moles, V, and 24. I prefer this. So importantly, if you rearrange it, volume will be the moles times 24, if you want it in decimeter cubed. So if we just apply this to some questions, we scroll down. What volume would 0.02 moles of hydrogen gas occupy? Well, volume is moles times 24. So 0.02 times 24 gives you 0.48 decimeter cubed. If the examiner wanted in centimeters cubed, you would times that by 1,000 and you get 480. One last example. How many moles of chlorine are there in 386 centimeters cubed of chlorine gas? So what you do is you find moles by doing V over 24. V is in centimeters cubed. So I would first divide it by 1,000. So I would get 0.386. Then I would divide it by 24. And I'll get this answer. They've used the alternative here, which is V over 24,000, because this was in centimeters cubed. As I said, it's the same effect. It doesn't matter if you first divide your centimeters cubed by 1,000, then by 24, or you do it in one step. Just don't mix the two up. For centimeters cubed, it's 24,000. For decimeters cubed, it's 24. That's kind of the important thing. I'm now going to go through some more examples for this and how it works. This is like the second formula you've learned. So remember, you know moles is mass over mR. Don't forget that. That's with masses. And if you're looking for volumes in gases, is this formula. So if I go to the first worksheet, I'm just going to go through like one example from each exercise. So number 1, I'm going to do A. Find the volume at room temperature and pressure. That's the clue for using this formula. So I'm going to just write the formula. Moles equals V over 24. And V equals moles times 24. So I know what I'm doing. So they want volume. So V equals N times 24, which equals moles is 4, times 24 is 96. But I must put the units. Because I use 24, I have to put decimeter cubed. As I said, if you want centimeters cubed, you times it by 1,000. So you see, this is actually easier than moles equals mass over mr, because you don't actually have to work out the mr or the ar. Okay, next we go through numbers 2 and 3, one example of each. There'll be full solutions in the answers, so you can practice these. 2a, find the moles. So moles equals V over 24. V is 48. Is it in decimeters cubed? Yes, it is. So I don't need to do anything. And the answer is 2 moles. If I'm doing this one, I would have to do 0.36 over 24, because you have to convert this to decimeters cubed first. This one's are going to be 2 steps. I'm going to go through 3b. So first of all, find the mass is the question. And you might say, well, hang on, that doesn't make sense. Moles equals V over 24, where the hell is mass? Well, don't forget your first formula of chemistry. Moles is mass over mR. So mass is moles times mR. So the idea is if you find the moles first, you can use the previous equation. So you're using 2 equations. So to find the moles, you stick to the V over 24 because that's a volume. We go to centimeters cubed, we convert it to decimeters cubed. So 0.48 over 24 is your step 1. That's what will give you the moles. In this case, you'll get 0.02. Then your moles will equal mass, sorry, your mass will equal moles times mR. So 0.02 times the AR, since it's an element of nitrogen, is 14 times 2, 28. So you get an answer of 0.56 grams. In order for this to work, you must have converted this to decimeters cubed. Now, these are the main course questions, I would say. These are the types of questions you'll get in the full-on exam. Before, in reactant masses, we did moles ratio mass. Now we're going to do moles ratio volume. So I call it Mr. V. As an example, I'm going to actually do number 6 because it's got harder ratios. So Mr. V is what you're looking for whenever you see this. So moles ratio volume. Now I'm going to use a different first thing. So find the volume of carbon dioxide. So that's my question mark. And they give me the ethane, which is going to be this. They give me 6 kilograms, but I must turn it into grams. Okay, remember the standard unit is grams for mass. For volume is decimeter cubed. Now, I obviously cannot use moles equals V over 24 because I have no V. But I can use M over MR, the first formula that we learned. So to do that, what I do is I do 6,000 grams mass over the MR of this. Now remember, the big number doesn't count, but the little ones do. So 2 times 12, no, 6 times 1 makes 30. You get 200 moles. Now the ratio, what volume of CO2? 2 to 4, which is the same as 1 to 2. So 200 has to be doubled to get the moles of CO2. So once again, we know this one is 200. So this one must be 400 because 2 times 2 is 4. So 200 times 2 is 400. Now we can apply the volume formula, moles times 24, which is derived from here, or from the triangle if you prefer. Okay, if you prefer triangles. Now they haven't specified if they want the volume in centimeter or decimeter, so I'm going to use 24, which means my answer will be in decimeter. So 400 times 24 is going to give you 9600 decimeter cubed. If you wish to make it centimeters cubed, you would then add another 3 zeros because you times it by 1,000. And this is a full-on 3-mark question on volumes. So Mr. V, moles ratio volume. That essentially completes the volumes topic. However, I need to show you one little trick in the gas volumes 2 sheet. So there'll be another kind of few examples here. All these solutions are all written in the answers. So this is the one I wanted to show you. Now this trick will only work when they give you a volume and they're asking you to work out a volume. That's when this trick works. And it only works for gases, not for solutions. So it says, find the volume of oxygen that's made from 10 decimeter cubed of sulfur dioxide. What you do, actually, just look at the ratio. The ratio is 2 to 1, so 10 goes to question mark. 2 goes to 1, so 10 must go to 5. Decimeter cubed, because this is decimeter cubed. Now you might think, well, that was too simple. Why don't you do the 3 steps? I'll show you why. If you do the 3 steps, which is moles, ratio, volume, then your moles will be 10 over 24 for the first one. Your ratio will be 2 to 1, so then you would divide it by 2. But then, to convert it to volume, remember volume is moles times 24. You would then times it by 24. So there's absolutely no point in dividing it by 24 in step 1 and timesing it by 24 in step 3. These two will cancel. So you're essentially doing 10 divided by 2 is 5. So that only works for gases because to find the moles, it's always divided by 24. It doesn't work for solids because they depend on the MR or the AR, and all the solids will have different MRs or ARs. So let's look at one more example, 2. Find the volume of hydrogen from 200 of nitrogen. Well, the answer will be the ratio is 1 to 3. So 200 will go to 600 centimeters cubed because they use centimeters cubed. And that's how you do these. Now, this, as I said, only works with volumes of gases. So when you get down to question 1 to 4 will be fine for that. But number 5 and 6, you can't do that. So I shall show you a final example with number 5 and then conclude. So number 5 says find the volume of CO2, but they give you the mass, not the volume of propane. If they gave us the volume of propane, it would have been easy. But instead they gave us the mass. So if you remember Mr. V, moles ratio volume, moles is mass over MR from the very first beginning. So MR of this is 12 times 3 plus 8 times 1. So that's 44. So that gives us this many moles. The ratio, so Mr. ratio is 1 to 3. So that means we have to triple this. When you triple it, you get 0.681 with a bit of rounding. Don't actually round, use the exact values on your calculator, remember, otherwise you'll lose the 1 mark for accuracy. Now they want the volume, so volume, remember, is moles times 24. So 0.681 times 24. And that will give us 16.4 decimeter cubed, remember, because we used 24. If you used 24,000, you would have got it in centimeters cubed. So that's a lot of technicalities, but you've now looked at how to use 2 formulas. Moles is mass over MR, and moles is volume over 24. For solids, we use mass over MR. We're dealing with volumes of gas, and there's no solutions going on. So they're just gases. We use V over 24. Next lesson, we will look at solutions and molar concentrations, which you'll be happy to know is the final of these mole calculations. The only other little bit is in the energetics topic. But this is where you're almost there now in terms of the calculations. So I will see you next time.